Now we have already seen about reflection of light from plane mirrors. Now mirrors need not always be plane. Even curved surfaces can also act as mirrors. Okay, reflection of light through curved surfaces. Now what is this curved surface? What are that mirrors? We'll see now. Okay, now a mirror in which the reflecting surface is curved or spherical. Curved or spherical, then is called as a spherical mirror. Okay, a mirror in which the reflecting surface is curved or spherical is called a spherical mirror. Now suppose that this is the sphere. Okay, now a spherical mirror is a part of a hollow glass sphere with one of its curved surface polished while the other surface is reflecting. Now suppose that this is a sphere and this is the part of the sphere. Okay, now this is a part of the sphere in which one is curving inside, the other one is bulging outside. Okay, now if in curving inside surface is coated with silver and the bulging outside part is reflecting, then this is called convex mirror. Okay, it is called convex mirror. A convex mirror in which a inward surface, curving inward surface is coated with silver and bulging outside surface is reflecting, then it is convex mirror. Now if you take another diagram in which silver coating is done on the bulging part like this, and inner side of the curve is reflecting, then it is called concave mirror. Concave mirror. Both the spherical mirrors are a part of sphere, but in one mirror the silver coating is inside and the other mirror the silver coating it is outside. Okay, now let us discuss some of the terms related to spherical mirrors. Okay, first one, linear aperture. Linear aperture. Now if you see the diagram, let us see in case of concave mirror first. Now if you see the diagram, now these are the extreme points of the part of the sphere, that is mirror. These 2 points are the extreme points. Now if we join these 2 points like this, then this distance between the 2 extreme points on the periphery of a spherical mirror is called linear aperture, and these 2 extreme points are denoted by M m dash. Okay, I will define with that. Linear aperture can be defined as the distance between two opposite extreme points on the periphery of a spherical mirror spherical mirror is called linear aperture, which is denoted by m dash. Okay, now let us go for one more term called aperture. Now aperture is defined as the area of the mirror from which the reflection takes place is called aperture. This is the area of the mirror from which reflection is taking place. Then this area is called aperture of the mirror. The area of the mirror from which reflection takes place. Is called aperture. Okay, right. Now we discuss one more term related to spherical mirror, that is pole. Now if you see the mirror, okay, this is the part of the sphere which is acting like a concave mirror. Now geometric center of this spherical mirror is called pole of the mirror. This is the geometric center from starting from this point to here. If you take, then the center of this mirror is nothing but pole of the mirror, which is denoted by P. Okay, how will we define it? Pole is the geometric, or we write it as geometrical center of the spherical mirror is called pole of the mirror. It is denoted by P, and pole is also called as optic center. Okay, optic center. Now we will go for new term, which is center of curvature. Now again, if you take this diagram, now this is the sphere for which there will be a center, and that center of the sphere or spherical sphere is called center of curvature. This one is called center of curvature. How will you define is the geometrical center of the hollow sphere of which the spherical mirror is a part is called center of curvature. Okay, we will write the definition. The geometrical center of the hollow sphere of which the spherical mirror is a part is called center of curvature, and it is denoted by a letter C. Okay, now we'll go for one more term called as principal axis. Now we have already seen that this is the center of curvature. Okay, now if take about principal axis, which is a straight line passing through the pole and the center of curvature of the spherical mirror is called principal axis. Now this is a straight line connecting or joining the pole and center of curvature, which is called principal axis, which is in short written as principal axis. Now we'll write the definition. The straight line, passing through the pole and the center of curvature of the spherical mirror is called principal axis. It can be represented from P to C, or we can extend this from here to here, even up to here. If we taken as x, now we can represent it from P to x, which is called what we call principal axis. Now we go for the new term called radius of curvature. Now if you see the diagram again, this is the pole, this is the center of curvature, nothing but center of the sphere. Now radius of curvature can be defined as the distance between pole to the center of curvature is defined as radius of curvature, nothing but here to here. So pole to the center of curvature is called radius of curvature, or else we can also define this as the radius of the hollow sphere, of which the spherical mirror is a part, is called radius of curvature, and it is denoted by a letter R. We will go for a new term called angular aperture. Okay, now suppose if we join the two extreme points M and M dash to the center, M dash to the center, these two extreme points subtend certain angle at the center of curvature. Now this angle which these two extreme points subtend at the center of curvature is called angular aperture. Okay, now we will write the definition for angular aperture. Now the angle subtended by the two opposite extreme points on the periphery of a spherical mirror at the center of curvature is called angular aperture. Okay, at the center of curvature is called angular aperture, which is denoted by M, C, M dash. Okay, nothing but angle M, C, M dash. Okay, this terminology which we have discussed for concave mirror is also explained for convex mirror also. Okay, now we will see for convex mirror. Now what here it is, this is the convex mirror in which inward or curving inward side is silver coated and the bulging outside surface is reflecting surface. Now in this is the extreme point where we consider this as M, and this is the another extreme points M dash. Now the distance between two extreme points M, M dash is called linear aperture. In case of concave mirror also this is what you call linear aperture. Here also it is linear aperture. Now the geometric center of this mirror is called pole, denoted by P. Okay, now again aperture nothing but the area of the mirror from which reflection takes place is called aperture. Now this is aperture in case of convex mirror. Okay, now again center of curvature nothing but this is the geometric center of the hollow sphere of which this spherical mirror is a part, which is denoted by a letter C. Okay, again if we take the principal axis is the imaginary line or straight line passing through the pole and connecting the center of curvature throughout. Okay, now if we indicate this point as X, now here P and X, P to X denotes the principal axis. In short we write as PA. Okay, now radius of curvature, the radius of curvature of the hollow sphere which the spherical mirror is a part and which is denoted by capital R. Nothing but the distance between pole to the center of curvature is called radius of curvature, which is denoted by capital R. Now again one more term, angular aperture nothing but if we join these two extreme points of the mirror to the center of curvature, then these two extreme points subtend an angle at the center of the curvature, then this angle subtended by these two extreme points is called angular aperture of the spherical mirror, denoted by MC M dash, means angle MC M dash. Okay, now let us discuss one more new term called focus or focal point and focal length. For that, let us consider a part of the sphere, nothing but a spherical mirror. Now here, which is a part of a spherical mirror, in which one surface, bulging outside surface is coated and curving inside surface is reflecting, which is called concave mirror. Now this is a concave mirror. As we have already seen that geometric center of the mirror is pole and geometric center of the sphere is called center of curvature, and the line joining the pole and center of curvature is principal axis. Okay, this one we have already seen in the last topic. Now in order to know the focus or focal point, we need to consider certain rays which are coming from the distant object which are parallel to each other, means parallel rays coming from the object we need to consider. Now these are the incident rays which are coming from the distance object, incident ray. So we need to give the arrow mark for the rays towards the mirror. So these are all the incident rays. So in order to draw the reflected ray, as we have already seen in case of a reflection at plane surfaces or plane mirror, we need to draw the normal, then we can draw the reflected ray. In order to draw the reflected ray, we have to draw first normal. So in case of curved surfaces, normal at the point of incidence always passes through the center of curvature. We have done an activity in the previous class that a normal drawn at the point of incidence. This is the point of incidence. If we draw a normal at this point, then it is proved that always normal passes through the center of curvature. Now this is the normal which is drawn, which passes through the center of curvature. Okay, now if we take this incident ray, okay, ray 1, then this is incidenting on the mirror at this point. Now this is the normal. Now this is the angle of incidence. Now according to laws of reflection, it will get reflected with the same angle of incidence but in the opposite direction to the incident ray. So incident ray will be on the one side and the reflected ray will be on the other side. Now this is the side through which the reflected ray will get passes with the angle of incidence. Okay, so angle of incidence always equal to angle of reflection. Now this is the reflected ray where this is called angle R. Okay, this is the first ray. Now this is the second ray. For this also the ray gets reflected and it will be passing through the principal axis like this. Okay, now the rays which are passing like this below the principal axis will be reflected and will be passing through the principal axis on the other side of the normal drawn here. Okay, ఇది నార్మల్, దీనికి వన్ సైడ్ ఇన్సిడెంట్ రే ఉంది, అదర్ సైడ్ రిఫ్లెక్టెడ్ రే ఉంటుంది. ఓకే, నవ్ అగైన్ ఇఫ్ యు టేక్ దిస్ రే, నవ్ దిస్ ఈజ్ ద నార్మల్, దిస్ ఈజ్ ద యాంగిల్ ఆఫ్ ఇన్సిడెన్స్. Now with the same angle it gets reflected. So if you draw the reflected ray, it passes like this. Okay, now these are all the reflected rays. Okay, drawn with brown color sketch are the reflected rays passing like this, and all are crossing the principal axis, and while they are passing along the principal axis, then they are meeting at this particular point. So all the rays, all the incident rays which are parallel to the principal axis, incident on the mirror, after reflection, they are meeting on the principal axis at a single point. This point where all the reflected rays are meeting is called focus of the mirror. What we call it as? We call it as focus of the mirror, which is also called focal point. Also called focal point. Now we got a new term, focus or focal point, which is denoted by capital F, which is denoted by capital F here. Okay, now if we see the diagram again, now this is the pole, now this is the capital F. Now there is a distance between pole to the focus. Now this distance from pole to focus is called focal length, is called focal length. Okay, now we will write the definition for focus or focal point. It is the point, okay, the point on the principal axis, the point on the principal axis where all rays of light parallel to the principal axis, parallel to the principal axis meet or appear to come from after reflection is called principal focus of a spherical mirror, and it is denoted by capital F. It is denoted by capital F. Okay, now we have seen that all the reflected rays after passing through the principal axis, they are meeting at this particular point. So we call concave mirror as converging mirror. Concave mirror is also called as converging mirror. Okay, now this focus we'll see in the convex mirror also. Okay, now this is again the part of a sphere. Okay, now if it is coated inside, or the inside surface is silver coated and the outside is reflecting surface, then we call it as convex mirror. As we have already seen, this is the geometric center of the mirror, which is called pole, and this is called the center of curvature, denoted by C. And if we join the line or imaginary straight line passing through pole to the center of curvature is called principal axis. Now if we consider few rays coming from the object which is at infinity, called incident rays, these are all incident rays coming from the object and incident on the mirror at a particular point. Okay, now this is the principal axis. Okay, now after incidenting on the mirror, the rays gets reflected, and in order to draw the reflected ray, always we need to know the normal, and according to our experimental evidence, normal always passes through the center of curvature. Now this is the point of incidence. In order to draw the reflected ray at this point, we need to draw the normal at this point, and that normal always passes through the center of curvature. Now this is the normal passing through the center of curvature. Now if we take this ray and if we draw the normal at this point, again normal passes through the center of curvature. Okay, now again if we take the another ray below the principal axis, now this is the point of incidence. Now if we take here, this is the normal, and again for the another ray, if we take the normal, which is always touches the center of curvature. So these are the lines drawn with the green color or the normals. Okay, now according to the laws of reflection, we know that for the normal, one side there will be incident ray with angle of incident I, and according to laws of reflection, angle I always equal to angle R, and the reflected ray will be on the other side of the normal. So for one side of the normal there is incident ray, and for the other side there will be reflected ray. So this reflected ray will be passing in the upward direction like this. Now this is a reflected ray. Now as if it is coming from a point on the principal axis, it is getting reflected. Okay, now if you take this incident ray, again one side will be the incident ray, the other side will be the normal, other side will be the reflected ray for the normal, with angle of incidence, angle of reflection. Okay, now for this ray, the reflected ray will be passing like this with the angle of reflection equal to angle of incidence. Okay, again for this one, right, this is angle R, this is angle I. All the rays after reflection, if we extend back or if we extend inside the mirror, they are meeting at a particular point on the principal axis. Then that point where the rays meeting after extending inside is called focus or focal point, denoted by capital F. So in case of convex mirror, the rays after reflection diverging, okay, so that this convex mirror is called diverging mirror, and we need to observe that after extending the rays, reflected rays inside the mirror only, they are meeting on the principal axis. So we call this point as principal focus or focal point. Okay, but in case of concave mirror, all the rays after reflection, they are directly meeting on the principal axis, which is called focus. Okay, here also the distance between pole and focus is called focal length. A new terminology we got here, we call it as focal length. Okay, focal length. Here the distance between pole and focus is called focal length. Okay, here the distance between pole and focus is called focal length, denoted by small f. Okay, we'll write the definition. The distance between pole and principal focus is called focal length, is called focal length of the spherical mirror. It is denoted by small f. Okay, and experimentally it is observed that focal length is always half of the radius of curvature, or we can also write as radius of curvature is always 2 times the focal length. So r is equal to 2f, or f is equal to r by 2. Now here, so the distance from P to C is called radius of curvature, and the distance from P to F, means pole to focus, is called focal length. Okay, here also the same. In case of convex mirror, the distance from pole to center of curvature is called radius of curvature. The distance between pole to focus is called focal length, and here the distance between P to F and F to C is always same or equal, such that R is equal to 2F always. Okay.